The last topic of this section is the squeeze theorem. This is quite an advanced theorem, but quite useful. So let me use this graph to explain the idea. So suppose we have two functions, f and h, which bound the function g like this. Suppose we have this condition when around x equals a. So this function g is bounded by f and h. And so first condition is, well, our function g is bounded by f and h like this around x equals a, interval containing a. And one more condition is when you take limit of f and h, the limit is exactly some number L. Then you can tell the limit of g is nothing but L as well. So whenever we have two conditions, we can find the limit of g. So quick example, suppose we have a function f, so that this f is bounded by two functions. And you want to use squeeze theorem to find this limit. All right, first condition is, this first condition is our function, the function that we are after, is bounded by two functions. And second condition is the limit of this guy when your x approaches 2 is 2 times 2 minus 1 or 3. And then when your x approaches 2, this function gives you the limit 4 minus 4 plus 3. So look at those two limits. Two limits agree. So then what can you say about this function in the middle? The limit of this guy has to be 3. And that's the conclusion of the squeeze theorem. So this limit is x approaches 2 is 3 by the squeeze theorem. So this example explains how we use squeeze theorem to find limit, the function in the middle. All right, the last example is quite advanced one. So we want to use the squeeze theorem to show that this limit is 0. This is a product of two functions, x and sine of 1 over x. When x approaches 0, this first term x is quite close to 0. What about this sine of 1 over x? Well, when your x is 0, 1 over x is huge number up to sine. So it's quite difficult to guess the limit of this product. So we want to use squeeze theorem. The first condition of squeeze theorem is to bound this function with two outer functions. Well, we can use the property of trigger function. Sine of 1 over x, sine of whatever, is bounded by two numbers. If you look at the graph of sine fluctuates forever with the maximum value 1, minimum value -1. So sine of whatever is bounded by 1 and -1. We are not done yet, but look at this expression, sine of 1 over x. This is quite close to our function that we are after. The only difference is x. So you multiply copy of x to get nice inequality. So if you multiply this x to this entire inequality, we have negative x, x times sine 1 of x, and then x. Look at this. We found the two outer functions that bound this copy of our function. So we are done with the first condition. Number 2, you look at the limit of two outer functions as x approaches 0. So limit of first function is 0, and limit of the second function is 0. So this guy goes to 0, this guy goes to 0. So that implies the middle function has to have the limit 0 as x approaches 0. So we are done. By the squeeze theorem, we have the limit is 0.